With few unexplored regions left on Earth for those with the itch for exploration, planets around other stars are the new terra incognita. This is one of the many reasons why astronomers and space agencies around the globe spend countless resources on the discovery of new exoplanets in the universe. Over the decades, scientists have uncovered certain planets that seem to defy all logic. Let's look at a few of these findings. The idea of life on other planets is old and can be traced back to ancient times, but until just a few years ago, this was all it was, an idea. The breakthrough occurred in 1995 when we discovered the first exoplanet, a planet in orbit around another star. Suddenly, we were a little less alone in the universe. Even though it is a young research field, the hunt for exoplanets has exploded in the last 20 years. Within this time, we have discovered more than 3,500 exoplanets and more than 4,000 unconfirmed candidates. On average, there is more than one exoplanet for every star, meaning that there are more exoplanets in the Milky Way than there are stars. Exoplanets are difficult to find. They do not emit light like stars. They are too small to block large areas of background light like interstellar clouds, and their mass is so small that their gravitational pull does not affect their surroundings anywhere close to the degree that dark matter can. We find most exoplanets with the so-called indirect method, which observes them indirectly, although we have been able to take images of some. The two most successful indirect methods are the radial velocity method and the transit method, which together have discovered over 95% of the exoplanets we know today. The methods are indirect because we do not observe the exoplanets themselves, but instead we observe how they affect the stars they orbit. When we found the first planet in orbit around another star in 1995, it was by using the radial velocity method. The method assumes that a planet pulls a little bit on the star that it orbits due to their mutual gravitational attraction. This causes the star to wobble a little bit while the planet moves around in its orbit. This causes a change in the wavelength of starlight that we record, called a Doppler shift. This means that the starlight is either red shifted when the star moves away from us, or blue shifted when the star moves towards us. We can find these planets by searching for a periodic red or blue shift in the spectrum of light emitted by its star. If the system is oriented such that a planet's orbit brings it in front of the star as seen from Earth, it will block out some of the star light. This is called a planetary transit, and using the transit method allows us to detect planets that periodically cast a shadow on their parent star. We've used the transit method to find most of the exoplanets that we know today. These methods have been incredibly successful in helping us locate some of the weirdest planets out there. Perhaps the planet which defies logic the most is WASP 107b. Discovered in 2017, WASP 107b lies about 212 light-years away in the constellation of Virgo. It orbits very close to its host star, completing a lap once every 5.7 days. It's about as big as Jupiter, but packs only 1/10 of its mass, making it one of the least dense planets that we know of. This incredibly low mass gives this planet the density of cotton candy. On closer inspection, astronomers have now found that its density is even lower than previously thought, defying our current understanding of how gas giants even form. In a new study, astronomers analyzed its most likely internal structure and found that the planet's solid core must have a mass of 4 Earths or less. That might sound like a lot, but by comparison, Jupiter's core has been estimated to have up to 25 times the mass of the Earth. The team calculated that the vast majority of WASP 107b's mass, over 85%, is contained in its gassy atmosphere. Neptune's atmosphere, for instance, only accounts for up to 15% of its mass. The weirdness might sound like nothing more than a numbers game, but it has some pretty major implications. Our current models for how gas giant planets form suggest that they need to start with a solid core of at least 10 Earth masses, which attracts gas from the protoplanetary disk surrounding young stars. The find suggests that gas giants form more easily than previously thought. The WASP 107 system will no doubt be the subject of future observations, and the recently launched James Webb Space Telescope will play a major part in helping shed further light on it. Gliese 1132b is a planet that is similar to Earth in a striking number of ways. Its radius is only slightly larger, as is its mass. Even its age, 4.5 billion years old, is similar to that of our planet. But this world does have one striking difference. It orbits much closer to its red dwarf parent star, completing an orbit in just 1.6 Earth days. This proximity results in Gliese 1132b experiencing a much higher surface temperature than our planet at 278 degrees Fahrenheit, with the intense radiation stripping the exoplanet's atmosphere. Yet, astronomers have recently discovered that something extraordinary is happening on Gliese 1132b. The gravitational influence of its star, 20% larger than the Sun, creates intense tidal forces that squeeze and stretch the planet. This flexing gives rise to violent volcanic activity and causes gases to rush to the world's surface. According to NASA, these gases are building the world a second atmosphere. While this is exciting in itself, being the first instance where astronomers have ever spotted anything like this, the regrown atmosphere, due to its origin, also provides astrogeologists with a unique opportunity to study the interior chemical composition of an exoplanet by proxy. Spotted in 2013 and further investigated by the Very Large Telescope in 2020, WASP-76b is a planet that is tidal locked to its parent star, BD 01316. This means that one side of the planet permanently faces the star, causing scorching hot temperatures of around 4,532 degrees Fahrenheit, hot enough to vaporize iron. The star-facing side of WASP-76b is roasted by radiation that is thousands of times more intense than that which Earth receives from the Sun, while the side that faces away from the F-type star experiences perpetual night. Yet even though the day side of the planet experiences hellish temperatures, that doesn't mean that conditions on the night side are a walk in the park. The side of WASP-76b that faces away from the planet's parent star is cooler by at least 1,832 degrees Fahrenheit, but this means that when iron vapor is carried across the hemisphere by powerful winds, they are cooled, forming liquid droplets. These droplets of molten iron then fall, bombarding the cooler side of the planet. The key clue that allowed astronomers to discover the presence of these iron rains came when the espresso instrument on the Very Large Telescope was used to investigate WASP-76b's atmosphere, and no traces of the element were found on one side of the world. WASP-76b isn't the only planet that experiences nightmare rains of this nature. From space, the exoplanet called HD 189733b may appear to be a beautiful and tranquil world, resembling a giant glassy blue marble. With exoplanets, though, appearances can be deceptive, and this is the case for this gas giant planet that completes an orbit of its star in just 2.2 days. Its beautiful blue hue arises from its deadly weather, particularly the molten glass rains that pelt the planet's surface. Yet, this isn't the extent of the planet's almost maniacal weather conditions. The exoplanet, discovered in 2005 by both NASA's Chandra X-ray Observatory and ESA's XMM Newton's X-ray telescopes, also experiences winds of around 5,600 miles per hour. These supersonic winds cause the exoplanet's glass rains to arc sideways towards the ground rather than just falling, also picking up silicate particles and turning them into microscopic projectiles. HD 189733b isn't just interesting to astronomers because of its unusual and hazardous weather, though. According to NASA, the giant exoplanet has been observed to possess an atmosphere that is much larger than scientists would expect for such a world. This extended atmosphere works to catch more of the considerable radiation HD 189733b receives from its parent stars, thanks to its perilously close orbit, meaning the gas giant experiences temperatures as high as 1,700 degrees Fahrenheit. The fact that the exoplanet's atmosphere is capturing so much intense radiation from the stars of the HD 189733 binary system means that it is rapidly being stripped away to space. With so many planets in the universe, there is little doubt that astronomers will continue to discover even more worlds that defy all logic. If you enjoyed this video, please check out this one, which looks into the recent discovery of more than 300 million inhabitable planets with liquid water within the Milky Way. Do you think one of the planets out there is capable of sustaining life? Please share your thoughts in the comments section below.